Intro: CERN's latest shocking discovery. Inside the shadow of Geneva, under the world's surface, lies a wonder of human resourcefulness and a potential harbinger of annihilation. The enormous Hadron Collider, LHC. This machine is an uncommon device for researchers, empowering them to study subatomic particles and uncover the secret of the God particle, the Higgs boson. Famous physicist Brian Cox has made a chilling declaration that has blended miracle throughout the religious community, proposing that something significant has been found at CERN with implications beyond our current understanding. Before digging into the ramifications of Cox's assertion, it is fundamental to understand how the Large Hadron Collider works. By CERN, the LHC is a 17M ring of superconducting magnets and the world's most powerful particle accelerator. It stands as a zenith of human accomplishment, capable of reproducing the conditions of the universe's creation. This titanic design allows us to unlock the secrets of the universe, uncovering something real and potentially disturbing. CERN, established in 1954, is one of the world's most famous research institutions, containing 23 member states and an immense range of specialists. The LHC is CERN's focal project, but it is only one piece of a broad network of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to almost the speed of light, recreating the energy of the universe at the time of the Big Bang. The subsequent impacts generate temperatures millions of times hotter than the sun's core, with a complex arrangement of magnets directing the protons on their journey, while advanced cooling systems maintain the magnets at temperatures colder than space. The LHC's design is an engineering marvel, working deep underground and protected from cosmic radiation. The entire ring is cooled to a temperature colder than the vacuum of space, which is crucial for the superconducting magnets to function. Collisions occur at 4 points along the accelerator ring, each corresponding to one of the 4 main particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors capture the aftermath of collisions, allowing researchers to sift through the debris in search of the elusive Higgs boson, a particle key to our understanding of the universe's structure. The LHC is not only a scientific instrument but a testament to human creativity and aspiration. It represents our quest for knowledge and our desire to understand the fundamental forces shaping our universe. However, as we push the boundaries of our understanding, we must also consider the moral and existential questions that arise. What are the dangers of exploring the unknown? Could our quest for dominance inadvertently unleash forces beyond our control? What's happening at CERN right now? Within the hallowed halls of CERN, where the frontiers of human knowledge are continually expanded, a revelation has emerged that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a respected voice in particle physics, recently made a statement that has both amazed and frightened the scientific community. The goal of CERN's Large Hadron Collider is to recreate a miniature version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential outcomes of this goal, noting the LHC's remarkable ability to create new phenomena, including its potential to reveal the Higgs boson and study dark matter, a substance that constitutes a significant portion of the universe. The possibility of recreating a mini Big Bang is not just a theoretical concept. It is a tangible reality within the LHC. The conditions inside the collider mimic those that existed at the universe's inception, allowing scientists to observe the birth of existence itself. However, with such power comes great responsibility and potential risk. Consider the scenario where something goes disastrously wrong. In 1978, Russian physicist Anat Boryk experienced an accident at the Institute for High-Energy Physics in Russia, where a malfunction caused his head to intersect with a proton beam, resulting in severe injuries. Despite this, Boryk survived and continued his work, highlighting the immense power and potential risks of particle accelerators. The dangers associated with a particle accelerator like the LHC are not to be trifled with. The potential for unforeseen reactions and the manipulation of the very fabric of reality are genuine concerns voiced by some in the scientific community. One of the most significant fears surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of spacetime with such strong gravitational pull that not even light can escape. If the LHC were to produce such an entity, Even on a small scale, it might potentially consume the Earth from within. However, scientists at CERN have assured the public that any black holes created would evaporate almost immediately. Brian Cox explains the unexpected findings. Understanding how the LHC could produce a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at near-light speeds, the energy is so intense that it could warp the fabric of spacetime itself. Imagine a trampoline stretched tight with a heavy weight dropped onto it. The surface would warp, and if the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to create a gravitational anomaly. This intriguing yet alarming possibility has even caught the attention of prominent physicists like the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson might become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a vast event that could destroy the universe. Respected cosmologist Sir Martin Rees has also expressed concerns about particle accelerator experiments, including those at CERN. In his book Our Final Century, he revisits the potential risks of particle collider experiments, including the formation of vacuum instability. This instability could hypothetically trigger a phase transition that would ripple through spacetime, causing a catastrophe of unimaginable proportions. While these scenarios remain highly speculative, even a slight possibility warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The experts at CERN have meticulously assessed the potential risks associated with their experiments and implemented numerous safety protocols and safeguards to mitigate any potential dangers. However, scientific exploration inherently involves a level of uncertainty, especially when venturing into uncharted territories. The pursuit of knowledge has always been accompanied by risks, but it is precisely this willingness to push boundaries that has driven human progress. The LHC represents the culmination of decades of scientific advancement and international collaboration. Yet beneath its impressive exterior lies a domain of profound scientific inquiry filled with potential dangers and ethical considerations. Could this change physics forever? Atom symbol. The collider's primary goal of unraveling the mysteries of particle physics has led to remarkable discoveries, including the elusive Higgs boson. However, the immense energies generated within its confines also raise concerns about the potentially disastrous consequences of such an endeavor. While extensive safety measures are in place to mitigate risks, the possibility of catastrophic events, such as the creation of microscopic black holes or other unforeseen anomalies, cannot be entirely ruled out. As researchers continue to push the boundaries of our understanding, it is crucial to approach these investigations with a keen awareness of the potential outcomes and a commitment to transparency and public discourse. The LHC, with its unparalleled capabilities and potential for groundbreaking discoveries, stands as a testament to human ingenuity and the relentless pursuit of understanding the fundamental laws of the universe. However, beneath its awe-inspiring exterior lies a realm of significant scientific inquiry, replete with potential risks and ethical considerations. The collider experiments tap into energies and forces that are beyond the comprehension of most laypeople. The collision of subatomic particles at near-light speeds creates conditions akin to those that existed in the universe's earliest moments, allowing researchers to probe the fundamental building blocks of matter and explore the very fabric of spacetime. Yet the immense energies involved in these collisions also present critical risks, both known and unknown. One of the most pressing concerns surrounding the operation of the Large Hadron Collider is the potential creation of miniature black holes or other exotic phenomena that could have unforeseen consequences. While theoretical models suggest that any such black holes would be ephemeral and pose no threat to Earth or its inhabitants, the prospect of inadvertently unleashing forces beyond our control remains unsettling. Final thoughts and what it means for science. Additionally, the sheer scale and complexity of the experiments conducted at the collider necessitate rigorous safety protocols and oversight to minimize potential risks. The global community of scientists and researchers involved in the collider's operation is acutely aware of the need to prioritize safety and ensure that all experiments are conducted with the utmost care and responsibility. The Large Hadron Collider, with its remarkable ability to probe the fabric of reality, is not only a marvel of modern engineering but also a focal point of contemporary physics and cosmology. Its primary objective, to investigate the fundamental particles that make up the universe has significant implications for our understanding of existence. The LHC enables scientists to recreate conditions just moments after the Big Bang, providing a unique opportunity to study the Higgs boson and other fundamental particles. The Higgs boson, often referred to as the God particle, was hypothesized in 1964 by Peter Higgs and others as a crucial component of the Standard Model of particle physics. This model describes the fundamental forces and particles that constitute the universe. The discovery of the Higgs boson at the LHC in 2012 confirmed the existence of the Higgs field, an invisible field that gives mass to other particles. This discovery was a monumental achievement, validating decades of theoretical work and enhancing our understanding of the universe's underlying structure. As the Large Hadron Collider, LHC, continues to operate at the cutting edge of science, its exploration into the deepest realms of particle physics is poised to redefine our understanding of the universe. With each collision that takes place within the collider, new particles, forces, and phenomena are revealed. But beyond the fascinating discoveries, the LHC raises profound questions not just about the fabric of space and time, but also about the very nature of scientific responsibility. One of the most anticipated goals of the LHC is to uncover the secrets of dark matter, a mysterious substance that is thought to make up roughly 27% of the universe's mass, but remains entirely invisible to our current detection methods. Dark matter doesn't emit light or energy, making it undetectable by conventional instruments. Its existence, however, is inferred by its gravitational effects on visible matter, like galaxies and galaxy clusters. If the LHC is successful in producing dark matter particles in the lab, it would provide scientists with the direct evidence they've been seeking for decades, potentially unlocking one of the greatest mysteries in modern cosmology. In addition to dark matter, another promising avenue of research within the LHC is the study of antimatter. Antimatter is the counterpart to ordinary matter, with particles that are opposites of the familiar particles that make up the world around us. When matter and antimatter collide, they annihilate each other in a burst of energy. This phenomenon has fascinated scientists for decades, especially since it is believed that the Big Bang should have created equal amounts of matter and antimatter. Yet, the universe as we know it seems to consist entirely of matter, with very little antimatter present. Understanding why there is such an imbalance could provide crucial insights into the origins of the cosmos. The LHC's experiments also offer valuable information about quantum mechanics and the behavior of particles at the smallest scales. Quantum mechanics, which governs the interactions of particles on a subatomic level, is an area that continues to challenge our deepest understanding of reality. The LHC provides an unparalleled environment for studying quantum phenomena, including the behavior of quarks, gluons, and other elementary particles that form the very building blocks of matter. By delving deeper into quantum mechanics, the LHC could uncover new laws of physics that go beyond the current standard model and possibly explain some of the more perplexing aspects of the universe, such as why there is more matter than antimatter or why the universe is expanding at an accelerating rate. But even as the LHC continues to push the boundaries of human knowledge, questions surrounding its risks persist. While many scientists are confident in the safety of the collider, there remains a certain level of uncertainty due to the unprecedented conditions that the LHC creates. One of the more well-known theoretical risks involves the potential formation of microscopic black holes. These black holes would be incredibly small and would evaporate almost instantly due to a phenomenon known as Hawking radiation. However, the creation of any black hole, no matter how tiny, raises concerns about the potential for unforeseen consequences, even if the likelihood of such an event is extremely low. In addition to the possibility of black holes, there are other less well-known risks that could arise from the collider's experiments. For example, some scientists have raised concerns about the potential for creating strangelets, hypothetical particles that could have the ability to convert ordinary matter into strange matter, potentially destabilizing the fabric of space-time. While this scenario is highly speculative, it highlights the fact that we are dealing with forces and energies that are still not fully understood. As with any groundbreaking research, there is always a certain level of risk, and it is crucial to approach it with caution. To address these concerns, CERN has implemented extensive safety measures, subjecting all LHC experiments to rigorous risk assessments before they are carried out. The organization works closely with independent experts to ensure that all precautions are taken, and its research is subject to continuous scrutiny from the scientific community. Nevertheless, there is always the question of whether we, as a species, are fully prepared to manage the potential consequences of such a powerful scientific tool. The LHC represents a remarkable triumph of human ingenuity, but it also forces us to confront our limits in understanding and control over the forces we are attempting to manipulate. Despite the risks, the LHC has already provided transformative breakthroughs that have reshaped the field of physics. The discovery of the Higgs boson in 2012 was a monumental achievement, confirming the existence of the Higgs field and validating the standard model of particle physics. This discovery not only solved one of the most elusive mysteries of modern physics, but also provided a powerful demonstration of the potential of high-energy particle accelerators to answer questions that had stumped scientists for decades. Moreover, the technological innovations spawned by the LHC's operations are far-reaching. One of the most notable contributions has been the development of the World Wide Web. Originally conceived by scientists at CERN to facilitate communication and data sharing between researchers, the web has since revolutionized the way we live, work, and communicate. This is just one example of how the LHC's technological advancements extend beyond the realm of physics, creating new tools and methodologies that benefit society at large. However, these advances come with significant ethical considerations. As we unlock more secrets of the universe, we must also grapple with the moral implications of our discoveries. Should humanity be responsible for manipulating the very building blocks of the universe, potentially creating forces we do not yet fully understand? Is the pursuit of knowledge worth the potential risks to our existence? These are questions that cannot be answered solely by scientists, but require input from philosophers, ethicists, and society as a whole. The LHC forces us to confront not just the limits of our knowledge, but also the responsibility that comes with expanding those boundaries. The future of the LHC is filled with exciting possibilities. As scientists continue to refine their experimental techniques and push the collider to even higher energies, there is the potential for even more groundbreaking discoveries. The LHC may eventually answer questions about the fundamental forces of nature, the nature of dark matter, or the origins of the universe itself. But as we continue to venture into the unknown, it is crucial to maintain a sense of caution and ethical responsibility, ensuring that our pursuit of knowledge is tempered by a deep respect for the potential risks and consequences of our actions. In the end, the LHC represents a fascinating paradox. It stands as a symbol of human achievement and curiosity, capable of unlocking the most profound mysteries of the universe. Yet, it also serves as a reminder of the dangers and uncertainties that lie at the very edges of scientific inquiry. The road ahead may hold remarkable discoveries, but it is essential to proceed with a sense of humility, responsibility, and transparency as we continue to explore the frontiers of the universe.